Okay, geometers, welcome back. In this video, we're going to learn how to do some constructions. Our first three constructions all have to do with segments. And we are right here at L9, Segment Constructions Worksheet. And if you take a look at that worksheet, the first few problems, you're doing a bunch of calculations based on everything that you know about, everything that you know about segments, okay, like adding segments, segment addition postulate, that kind of thing. So you get to do some calculations, and then starting with 12, 13, and 14, this is where the fun of Euclidean construction starts. Okay, so there's three types of constructions that I'm going to teach you today. First is super easy. It's copying a line segment. So that's 12, 13, and 14. You're given a line segment. You're asked to copy that. Okay. Then 15 through 19, we're gonna add one more layer of complexity. Instead of just copying one line segment, you're going to be copying multiple line segments and adding them or subtracting them. Okay. Also very, very easy. Then finally, these constructions in 2021 and 22, you're going to take whatever segment that you're given and you're going to bisect it, which is pretty amazing. So if you think about Euclid, and we can really think back and appreciate Euclid and the ancient Greeks who discovered all of these constructions and proved that these constructions were actually true, okay, using nothing more than a straight edge and a compass and their brains. Okay, they figured out all of these geometric properties using these very, very basic tools. Okay, so remember that we're going to be doing constructions throughout the entire course, and all of the constructions that we're going to learn, if you forget how to do them, you can just type into Google Math Open Reference and go to constructions, and these are all of the constructions and more. Okay, we're not going to do every single one of these, but these are all the constructions that we're going to do are in this list, right? So here's all your line constructions that have to do with segments. Here's all your angle constructions. We're going to do things like bisect an angle, construct an exactly 90-degree angle, 60-degree angle. Pretty cool. We're going to do triangle constructions. We're going to copy two triangles exactly. All sorts of things, right? Including even constructing some of the basic polygons, okay? There's also a really cool introduction to Euclidean constructions, tools and rules. There's also printable construction worksheets if you want to use those. Okay, but basically when you click on these, like this is the first one that we're going to learn. Okay, this is a really cool website because it shows the actual proof for why this construction is true. And then it also gives you can print right here. This is a hyperlink. You can print this step-by-step instruction sheet, and you won't need it for these constructions today, but some of the ones get pretty, quite a few steps later on. So you might want to do that, okay? So when you go here, this is just an animation. It's an applet that just shows you an animation. So you can just click on run, and it'll run through the entire construction. And you can just watch exactly how to do the construction. This is super useful, especially for strongly visual learners. It's really nice to see this. Okay. The other thing you can do is just go next, and you can click through next, next, next. You can just go step by step, and then it will also tell you step one, mark a point R. That will be one end of the new line. Okay. And then it'll go step two, step three, step four. And it's very important that as you're following these steps and as you're doing these constructions, these really require precision. So you want to be slow and meticulous and precise as you're doing these constructions. Okay, you don't want to rush through. And some people have highly developed motor skills, so these are going to be fine motor skills, so these are going to be a lot easier for you. And then for some of us, these are, we're going to struggle because these are brand new, and we're not used to doing these kind of things that require this much sort of precision. But don't worry, because everybody will get better at these. It just takes practice. It's something brand new. So if you're struggling at first, don't be discouraged. Trust me, it gets easier the more you do it. Okay, and pretty soon you'll be a pro. Okay, so let's go ahead and go to, okay, here are some of the tools that I use. Okay, now I do not recommend using pen. In fact, I will say for sure do not use pen because your teachers will not like it. Okay, but I use pen because it shows up better on the document camera, and it's easier to see just for instructional purposes. Okay, what I do recommend is you can use colored pencil if you like. I know that some of you use colored pencils and highlighters and that kind of thing, and I think it's kind of cool to use colored pencils. Okay, but at a minimum, you're going to need a compass, and you don't need this type of compass. There's actually different types of compasses. This is called a bow compass. It has this little wheel in the middle, and the bow compass, what I like about it is that it really locks into position. Once you get it the right width, it doesn't change. The drawback to it is it's very slow because you have to turn this wheel. If you get impatient and you try to pull the legs apart, you're going to break it. Okay, but there are other compasses that do not have this bow, that do not have this little wheel, and you can just pull the legs apart, and so it's much faster. You just have to be a little bit more careful because as you're using them, sometimes the legs sort of slide apart. Okay, and we don't want that. The other thing you need is a straight edge. Okay, and for my straight edge, I'm actually just using a protractor because later on in the course we're going to use a protractor for angles. But I'm just going to use this straight edge of the protractor. And this protractor obviously has markings, has inches and centimeters and that kind of thing. But to really appreciate Euclidean constructions, just remember that they had no markings on their straight edges. Okay. All right, so here we go. So first thing is you're going to be given a line segment, and you're going to be asked to, the most basic thing is you're just going to be asked to copy a line segment. So let's say that we are given a line segment, okay, any segment. It doesn't have to be horizontal like this. It can be at any angle. Okay, let's say we have a line segment like this. And let's say they give us line segment AB, and our first instruction is simply to copy a line segment. Okay, so we're given a line segment, we're asked to copy it. I'm going to zoom in a little bit more. Okay, so we start with the line segment. So to copy this line segment, okay, what I do is slightly different than mathopenreference.com, and that's fine. Either way is perfectly, you're gonna get it right either way you do it. But what I like to do is actually start with array. Okay, so I start with just make a line that's much longer than what you actually need, and then put one endpoint on it. Okay, and let's call this A prime. Okay, this little mark up here above, this superscripted mark, that is called prime. You read that as A prime. The reason I'm calling this A prime is because it's not exactly A, because A is over here, but it tells you that A prime is related to this point A somehow. Okay, so now we just need to put B on this somehow. Okay, and we're not going to measure how many inches it is. That's not what we're doing. Okay, what we're going to do is we're going to put the pointy end, so there's the pointy end and the pencil end. We're going to put the pointy end on one end point of our original segment. It doesn't matter which one. Open up the compass so that the other end, the pencil end, goes right on B. And then now this is very important. Okay, we want to go ahead and make an arc on the original. If you don't make that arc, you're not going to get full credit. And Math Open Reference did not make an arc there. Okay, but I need to see that arc to give you credit. Then without changing your compass, I open my compass to this width, and I didn't change it at all. Then I just move the pointy end to A prime, and I make an arc over here. And that is going to be B prime. Okay, right where this arc intersects this ray, let's call that a ray, that is going to be B prime. So I know that these two segments are congruent. Okay, so I know that segment AB is congruent to segment A prime, B prime. And you didn't have to call this A prime, B prime. They might tell you in the instructions what to name this. They might have said, okay, name this segment CD, okay, or whatever. Then you would just have that, okay. just go ahead and make sure you're following the instructions. So that is it. That's all there is to copying a segment. Easy peasy. Okay, next construction. Let's say that we have two segments. So I'm going to start with this original segment, segment AB. And let's say I'm also given another segment somewhere else. And let's make it, whoops. Let's say I'm given this segment also. Segment AB and segment, well, I used CD, so let's call this segment EF. Okay, and then in my next construction, I'm asked to create a segment or construct a segment. Construct a segment whose length is equal to AB plus EF. Okay, so that's what we're going to do next. Okay, so this is super easy. All I'm going to do is just make one really long ray. Then I'm going to cut off AB. Then right next to it, adjacent to it, I'm going to cut off EF. So I'll show you what I mean right now. So I'm going to start with a long ray, and this is going to have to be pretty long. Okay, and this ruler's not that long. Go ahead and I'm going to lengthen it. Just be nice and precise with it. Okay, so here's my ray that I start with. Here's one endpoint. Okay, and let's call this construct a segment. Let's call it segment JK, such that JK is equal to AB plus EF. Okay. All right, so first I'm going to go ahead and put my compass on A to B, which it's already there from the previous exercise, and make an arc. Okay. Then I put my compass on point J, and I basically copy that arc over here. Okay, so this is point J. Now this line segment right here is congruent to this line segment AB. Okay. But what I want is also EF. So I'm going to put EF, I'm going to put my compass one end on E, open up the other end to F, make an arc. And it doesn't matter if I go F to E, okay? Because remember, these are directionless. It doesn't matter if I go backwards and put the arc on E. It doesn't matter, okay? But without changing my compass, so my compass is still open to this width, now I put my compass on this intersection, and I'm just adding on to it. So going in the same direction means I'm adding on, okay? So this is going to be right here, that intersection is going to be JK. So now I have constructed a segment JK, such that the length JK is equal to AB plus EF, okay? When I'm grading you on these, what I'm looking for are these arcs. This arc, this arc, this arc, and this arc. And I also have a tool that is like a compass, but it has just two pointy ends, no pencil end. And I can open up and check these and open up and check these. Now, if you're off by a little bit, okay, with those, because maybe your compass slid or, this is brand new motor skills for us, that's okay. Okay, so if this is not exactly perfect for right now, as long as it's very, very close, you're going to get full credit. Okay. The thing, though, is you have to have, how many arcs are there in this construction? 1, 2, 3, 4. You have to have all 4 arcs to get full credit. If you're missing any of these arcs, then you're missing points. If you go back and erase these arcs, then you're erasing your points. So remember that you're being graded on neatness, precision, but mostly having the number of arcs, so meaning following the correct steps. Okay, so if I were to then want to subtract, okay, remember that adding means you go in the same direction, and that makes sense intuitively, your segment's getting longer and longer and longer. But what if I wanted to subtract? Well, then you would just go in the opposite direction back that way. So for example, let's say that to JK, what I want to do is I want to subtract some arc, okay? So let's subtract, let's create an arc, and I don't know, let's not make it, okay, perfectly. Okay, let's go this way with it. And let's call this TV. Okay, and now let's subtract. Now subtract TV from JK. Okay, so we have JK right there. And now we want to subtract this length of this segment from it. So we're just going to go backwards. Okay, so what do? We just copy this segment, but we go backwards. Okay, so put the pointy end on T, open up your compass until the pencil end hits the other end point, V. Okay, and then to show that I've done that, I make an arc. And then I go backwards from K, I go backwards in this direction. And notice that the arc, I can tell when I'm grading these by which way your arc is bowed, right? So this arc is bowed this way. I know that you went backwards this way, okay? And let's call that JW. So this point would be W, okay? So this JW is equal to JK minus TV, okay? And I know that KW is also equal to TV. Okay, so that's how you add and subtract segments, okay? Our final construction is, and one other tip that I like to give you is that I have about 3 pieces of recycled paper here, and I always stack them, okay, when I'm doing constructions, because this pointy end, I want it to kind of go into the paper. It doesn't have to tear through the paper, but if I only have 1 sheet of paper, it doesn't work as well. Okay, so I always use like 3 sheets of paper. I wouldn't put it on top of a textbook because you'll possibly puncture the textbook. Okay, in our final construction, you're going to be given a line segment, okay, any segment. Let's just go this way with it. Okay, and let's just call this segment GH. And you're going to be asked to bisect the segment. Bisect segment GH. Okay, so we're going to cut this segment exactly in half. And let's just appreciate that Euclid and the ancient Greek mathematicians discovered how to do this with no measuring tools. They didn't go, oh, how many inches is it? Oh, 4 inches, 4 divided by 2. No. Okay, they just used a straight edge and a compass. So here's what you're going to do. Okay, you're going to take your compass and open it up to any length, okay, or any width, but anything that is greater than roughly where you think the midpoint of this segment is. So I think the midpoint of the segment is, I'm not sure, but I'm going to say somewhere in this neighborhood. So I'm going to open up my compass larger than that. Okay, you could open it all the way to point H, but you don't need to. Okay, so I'm going to open it up past where I think the midpoint is. Okay, so I put my compass on G, and then I simply make 2 arcs. Or I'm sorry, not 2 arcs, 1 really long arc, okay? And how long should this be? Such that, you know, if I'm eyeballing roughly where I think the midpoint is, like maybe there, this arc has to go beyond it, okay? It has to go to the left of it and to the right of it, okay? Now, without changing my compass, I'm gonna put my pointy end on H, and I'm gonna make that exact same arc, just like that, okay? And to me, this looks like a football, right? So I call this the football construction, okay? So what do? You see there's these 2 points of intersection. You simply connect the dots, okay? In other words, you put your straight edge right on both intersection points. And remember that my pen has some width to it. Okay? And there I have bisected this arc. And so let's call this point of intersection, let's just call it, I don't know, J. So I know now that these 2 segments are congruent. I know that segment GJ is congruent to segment JH, okay? And I have bisected this segment. And not only did I bisect this, but this is actually, it turns out that this is a perpendicular bisector. Okay, this line here, which I didn't make it a segment, array, or a line. Let's make it a line. This blue line is actually a perpendicular bisector. Okay. So when you're looking in mathopenreference.com, look for the construction that says perpendicular bisector. Guys, that's all we have. I hope you enjoyed this video, and I hope you enjoy your practice tonight.